Section 3 of Chapter 1 is adding and subtracting real numbers. And so you're going to think, oh, adding, I can do that, no problem. Don't tune out. Make sure you get all the parts and pieces and all the steps. You got it? All right, here we go. The first thing you need to remember is that when you're adding numbers with the same signs, you're simply going to add the numbers together and use that sign. So get your notes out and write it in here and put a big star on it because I want you to remember this. So you're going to add the numbers and use that sign. All right, so add the numbers and use that sign. So let's do a couple of examples. Of course, what you've done always with positive numbers, it's the same. 15 plus 13, you just add the two numbers is 28. And it's a positive. These are both positive, so of course it's positive. This is like if you have $15 in your pocket and somebody pays you for doing a great job and they give you 13 more, now you have $28. If you owe somebody $14 and then you borrow some more money from them, you're further in debt. So you'd add the 14 and the 23, what is that, 37? But you're further in debt, so it's still negative. So you're just going to add the numbers, 14 plus the 23, and you use the sign. The sign is negative, so your answer is negative. Got it? All right, let's move on. If you're adding numbers with different signs, now you're going different directions on the number line. So we're going to make money, but then we're going to spend money. And so in that case, we're going to find the difference between the two. So you're going to subtract the numbers. Make sure this is in your notes so you can go back to it. So you're going to subtract the numbers, and then the way you determine the sign is whichever number is bigger, that gets the sign. So if you borrow more money than you earn, then your answer is going to be negative. But if you earn more money than you spend, then you're going to have a positive answer. So you're going to subtract the numbers and use the sign of the larger number. Make sure this is in your notes. This is really important. All right, so negative 13 and positive 20, one is negative and one is positive, so you need to find the difference between the two. I owed $13, but I went to work and I earned 20 more. So the difference between the two is 7, and I earned more than I spent, so I have a positive $7 in my pocket. All right, same thing here. You've got a positive 12 and a negative 18 that you're adding together. The signs are different. So you're going to subtract. So you're going to take the 18 minus the 12, and that's 6. But the 18 is bigger than 12, and the 18 is negative. So your answer is a negative 6. So in other words, you had $12 and you borrowed 18, so now you're actually in debt $6. So that's where those positive and negative numbers come from. There are, there are some more practice problems like that, I believe, on page 24. So check those out, do a few, and then come back. So make sure you know that. These rules, these same rules, the adding if they're the same and subtracting if they're different signs, those same rules apply to fractions and decimals. So you need to learn the rules for adding and subtracting fractions as far as getting like denominators and lining up decimals. But as far as the signs, the positive and negative signs are concerned, those rules are exactly the same. So let's just do a couple of fractions. So when you're adding fractions, you got to have like denominators. The reason for that is the denominator of a fraction tells you how big your piece is. How many pieces did I cut my pie into? So if we're counting pieces of pie, if I have 3 pieces from this pie and 6 pieces from this pie, but the pieces are different sizes, then my total means nothing. The pieces have to be chopped into the same size in order for that fraction to make sense. So that's why if I've got 1/6 of a pie and 5/9 of a pie, I've got to do some cutting to make sure that those pies are the same size so that I can find out what kind of piece I have involved here. So we know they're both positive, so we're going to add them, but we have to have same denominators in order to fraction. In order to add those fractions, we've got to get like denominators. And we did that in section 2. So we're looking to see the least common denominator of 6 and 9. So 6 times 2 is 12, 6 times 3 is 18. Ooh, and I happen to know 9 times 2 is 18. So I'm going to use 18 as my common denominator. So to get 18 in both of my denominators, I got to take 6 times 3 to get 18 and 9 times 2 to get 18. So to get your numerators, don't forget, in order to get the numerators, you've got to multiply the denominator and the numerator by the same thing. So this fraction, I multiplied the denominator by 3, so I have to multiply my numerator by 3. 1 times 3 is 3. I multiplied this denominator by 2, so this numerator has to be multiplied by 2. 5 times 2 is 10. So then, all right, so I haven't been talking through these steps. So get like denominators. That's what we did. Oh, these are the steps. So we just got like denominators and found our numerators. Now the next step is just add the numerators. So 3 plus 10 is 13. Keep the same denominator. The reason for that is that 18 is the size of the piece. The size of the piece doesn't change when you add them. Now I have 3/18 of a pie here. I have 10/18 of a pie here. I'm just adding them up and putting them into the same pan. And I'm counting them. There are 13 pieces, but the size is still 18ths. It takes 18 of those pieces to make the whole pie. So 13/18, and then the last step always is to simplify. And in this case, 13 is prime, and 13 won't go into 18. So I'm simplified, and that's my final answer. All right, so now let's add the step in of having different signs. So here again, we've got different denominators. We've got to get the same denominator. We got to chop those pies into the same number of pieces. So 5, 10, 15, 20, 3, 6, 9, 12, 15. Oh, there it is. 15 is my like denominator. All right, so 5 times 3 is 15. So I've got to take the 4 times 3, and so that's 12. And now remember, this is negative, so you got to bring the negative over. Do you remember that with a fraction, if your whole fraction is negative, you can put that negative onto your numerator, and it's the same thing as when the whole fraction is negative. All right, so I'm just going to move that up to the numerator and say negative 12. So my 3 times 5 is 15. So I've got to take the 2 times 5 is 10. So now I've gotten my like denominators. First step is done. The next step is to add the numerators. Now remember, when we're adding, if you've got a negative and a positive, if you're adding different signs, do you remember from up here, we actually need to subtract the numbers. So 12 minus 10 is 2. The larger number is the 12. And the 12 is negative. So we have a negative 2, and your denominator is 15, and 2 will not go into 15. So I should have done some that you had to simplify, but I didn't. So there you go. Negative 2/15. Hopefully you remember how to simplify. All right. So then, yes. Okay. All right, what's next? What's next? I did it wrong on my notes and it's confusing me. Okay, so the next thing we want to do is, we said with fractions and decimals we use the same rules, and we did fractions. So now let's do decimals. With decimals, if you'll remember, tell you what, I'm all out of whack today. Here's the eraser. All right, with decimals, remember, you've got to line up the decimals when you're adding and subtracting, because we want to add and subtract the same place values. The decimal indicates what place value you've got. So, so we've got to make sure that the place values are lined up. Let's just bring a problem here. Angela has a balance of $578.26, and she incurs a debt of $92.45. She goes shopping. What is Angela's new balance? So what we've got to remember is the balance is $578.26. That's positive. So $578.26 is the balance. And a debt of 92.45, a debt is actually going to be a negative number. And so what's going to happen here, and you're looking and you're saying, well, that's a subtraction problem, and it is. But what we're doing is we're adding a positive number and a negative number together, and it ends up looking like a subtraction problem. So line up the decimals and bring down your decimal, and then just subtract. 6 minus 5 is 1. Got to borrow. 2, 3, 4 is 8. 5, 5, 4. Hey, you should do this on your own and then come back and see if we get the same thing. 7, 8, 9 is 8. 485, 81. I hope that's what you got. That's what I got before. All right. So then this, I said, looks like a subtraction problem. Let's talk about, well, what is subtraction? In order to talk about subtraction, we first want to talk about an additive inverse. The term additive inverse simply means the opposite of a number. All right? The opposite. And so what that means is if I add this number and its additive inverse, I'm going to get 0. The two added together equals 0. All right, the two numbers added together equals 0. So if you've got the number 9, the additive inverse is going to be the opposite, which is just negative 9. If you've got a negative 7, the additive inverse is the opposite, which is just 7. Here's a trick. 0, the additive inverse is actually going to just be 0. And the trick with that is the two added together equals 0. So 0 plus 0 does in fact equal 0. So 0 doesn't really have an additive inverse. It is its own additive inverse. So the additive inverse means the negative of something. So if I say the additive inverse of negative 8, that's what this is. Negative 8 means the additive inverse of negative 8. So the opposite of negative 8 is simply positive 8. So in other words, if you have two negatives make a positive because you're saying the opposite of a negative. The opposite of a negative is a positive. If you have, do you remember that these bars mean absolute value? The absolute value is a distance, and that distance is always positive. So the absolute value of negative 6 is positive 6. But the opposite of the absolute value of 6 is negative 6. All right? So the reason that's important is because when we subtract, that means we're going to add the opposite. So we're going to use the additive inverse or add the opposite. So let's get a couple of examples here. So negative 15 minus a negative 6 and negative 5/8 minus 3/8. So you might want, if you think, oh, I think I've got this, then go ahead and pause the video and come back and see how you did. All right? Because remember, when you subtract, that means to add the opposite. So we're simply going to change this subtraction sign to an add, and then whatever this sign is, we're going to change it to the opposite. So now we have the same rules that we had before, where we're adding two different signs. We're going to subtract, and then we're going to use the sign of the larger. So 15 minus 6 is 9. 15 is larger, and it's negative. So negative 9 is your answer. So anytime you're subtracting, you're going to change the sign of that second number. The first number, leave it alone because you're adding the opposite of what's right after it. So negative 5/8 minus 3/8, this simply means, well, I'm going to add the opposite of 3/8. So I'm going to add a negative 3/8. So now you go back to, well, if you're adding and the signs are the same, now we're going to add. The denominators are already the same, so we don't have to do that step. The signs are the same, so we add. 5 plus 3 is 8. And the signs are negative, so your answer is negative. And then you can reduce this down to just negative 1 because 8 and 8 are the same and they can both be divided. The same exact thing happens with subtracting or with decimals. If you're subtracting with decimals, you're going to add the opposite. Let's look at a word problem that has that in it, because I know you love word problems so much. On Mars, the daytime temperature can reach negative 15 degrees Celsius, while at night the temperature can plummet to negative 140 degrees. What is the difference between the high and low temps? So because we want a difference, we want to subtract. So we want negative 15 and we want the difference, so we're going to subtract a negative 140. So when we do that, subtracting a negative means we're going to add the opposite. So when I subtract 15 from 140, I get 140, 130, 125. And the 140 is bigger, so my answer is positive. So 125 is the difference between the high and low temperatures. There's 125 degrees difference between the two numbers. All right, I have gone fast and furious through lots of different things that use the same types of steps. So if you would like to go through some of the Your Turn activities in the lesson, they have more examples, and they have problems you can work out, and then the answers are right there in your book. So I encourage you to go through those. We'll work out some problems in class tomorrow. I will see you then.